We at Dance Manchester are delighted to be working with the Fascinate Hub at the University of Manchester, which has enabled us to bring together a Manchester-based choreographer with two renowned astrophysicists for a project exploring star formation and the sun through creative dance.
This project is really fascinating in itself. It's bringing together a leading scientist with a dance choreographer and a brilliant group of schools to really take an aspect of contemporary science and make it more understandable to lots and lots of different people and outstretching to the public as well. And that's really at the heart of what we're aiming to do. We really want to make science accessible. We want to make it a subject which does fascinate and inspire and comes to life for youngsters.
Hi, my name's Bridget Fisk. It's been my absolute pleasure to be working as the choreographer on this project. I've had an incredible time collaborating with the two astrophysicists, learning new things myself and going on the journey of creating movement motifs and choreographic tasks that allow that knowledge from those sciences to be communicated.
So I'm Dr. Roundsmith. I'm an astrophysicist at the University of Manchester, and my research looks at how stars form. And I study this using huge numerical simulations using supercomputers. So today I'm just going to tell you a little bit about the physics behind how stars form. So in section 1, we're going to look at the stellar nurseries where the stars form. And these are huge clouds of molecular gas in space. They are mainly made of a little bit of dusty kind of silicate and carbon particles, but mainly molecular H2 molecules. Now, these clouds are incredibly hot, minus 206 degrees Celsius, and while here on Earth we'd think they were a vacuum, for space they're very dense. They have dynamic supersonic motions throughout them, which increases the density and forms a network of filaments throughout the cloud. In these filaments, dense cores of gas can form, like beads along a string, and it's these cores which will collapse to form stars. Section 2, we're going to look at these collapsing cores of gas. Now, what's really important here is the balance of forces. On one hand, we have gravity trying to pull the core together. On the other hand, we have thermal energy trying to make the core expand. When gravity wins, the core can collapse, causing the gas to fall towards the centre. And it's at the centre that the star will form. Now, what we find is if the core had a little bit of spin at the beginning, this spin increases due to conservation of angular momentum and is much faster at the end of the star when you have this protostar. And so what you get is a disk of gas surrounding this very dense ball of gas at the centre. Now, at the centre of this ball of gas, the density, the temperature, the pressure is so high that hydrogen atoms can fuse together to form helium instead. And the extra energy from this process is released from the centre and will end up being starlight, and is basically energy that powers all the life here on Earth.